Okay, so now we've got our first real problem-solving question here. We've got a pendulum clock which keeps perfect time at a location where the acceleration due to gravity is exactly 9.8 meters per second. We're going to move it to a higher altitude. Now recognize that moving it to a higher altitude means it's going to be farther from the center of the Earth, so therefore your acceleration due to gravity should decrease. Now it says when the clock is moved to a higher altitude, it loses 80 seconds per day. So we're going to try to find the value of g at this new location. All right, so the first part of this is to figure out how big of a deal is that 80 seconds per day, a minute and 20 seconds, right? So what we're going to do is we're going to find out how many seconds there are in a day. So 60 seconds per minute, 60 minutes per day, and then 24 hours per day, because it says it loses 80 seconds per day. So let's find out how many seconds there are there in total. So I get 86,400 seconds. Now, when it's moved to the higher altitude, I'm losing 80 seconds. That must mean that I get 86,320 seconds instead. So how is the period of this related to the period of that? It must mean that my pendulum is swinging slower than it used to, right? Because it's not getting through quite as many ticks as it did before. It's losing some of those. And so therefore, the period must be longer than it was before. How much longer? Well, I can actually find out just by dividing these two, right? So I go 86400, and I divide by 86320, and what I get is a number which is very close to 1, but not quite. I get 1.000926, and then it goes on, 784. This is an exact number, so I can go ahead and keep as many of those digits as I want. But what that means is that the period needs to be slightly longer than it was before. So now I should be able to just take my equation for period, which is that the period of a pendulum equals 2 pi square root L over G, right? And we know that this number needs to be this much larger than it originally was. So what I'm going to do is I'm going to actually solve for G here, right? So the 2 pi is going to be a constant, okay? The square root of L is a constant because I'm not changing that. So if I rewrite this, the period needs to be equal to 2 pi square root of L times 1 over the square root of G. Okay? Now, this has to be related to the original period. Now, that original period was 2 pi square root of L times 1 over the square root of 9.8. Right? So you'll notice that the TP, the period over the initial period, that's the number that I just found. That's the ratio of the periods. My new period needs to be that much longer. So it's going to be 1.000926,784. The 2 pi's, that's going to be the same. The square root of L, that's going to be the same. And so when I divide these two, I'm going to end up with the square root of 9.8 over the square root of my new G, because it's going to be 1 over square root of G divided by this, and when you divide, you multiply by the reciprocal. That's going to put this guy up on top. And so now I should just be able to solve, right? I'm going to move the square root of G over there. I'm going to divide by this, and so just on my calculator, I'm going to go 9.8, and I'm going to square root that. And then I'm going to divide it by that 1.00926784. And I get that the square root of G is equal to 3.1275, la 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 la. Now I'm going to go ahead and square that. And I get that my new G is equal to 9.78 meters per second squared. So we get what we expect, which is that the gravitational field, the strength of the gravitational field, or the acceleration due to gravity, is slightly less, which is 9.78 meters per second squared. All right, so I hope that was helpful. All we did was we found a ratio, Then we used the ratio with the equation here. We canceled out the stuff that was common, and we used what was left in ratio form in order to calculate what the new G had to be. Now, there are other ways to do this, right? You could make an assumption, for example, that the period is 1 second, right? And you could say the period is 1 second. In order for the period to be 1 second, then what does the length need to be if gravity is 9.8, right? And so we could have gone 1 equals 2 pi square root of L over 9.8. And then you could solve for L. Once you solve for L, then you could set up a new situation where you would need to find out what the new period needs to be, losing 8.0 seconds, 80.0 seconds per day. This is going to be your new period essentially right here. If the original period was 1, your new period would need to be this. So you can find out what your new period was, set that equal to 2 pi square root. You just solve for L, you could put that L, and then you could solve for your new G. And that way would work too. There's lots of different ways to answer this. I like using ratios just because it gets rid of all that stuff. I don't actually have to worry about it, the L in the middle, but it does take some practice and getting used to. All right, hope that was helpful.